Good morning, dear students. Today we have discussed about one of the experimental proof for dual nature of electrons from first module quantum mechanics. Let me start the topic. Okay, so de Broglie explained about just a theoretical explanation about electron dual nature. According to de Broglie hypothesis, he calculated electron wavelength by taking momentum and wavelength relationship, that is lambda is equal to h by mv, but it was not explained experimentally. So Davisson and Germer first demonstrate experimentally these were explain dual nature of electron with experimental setup. It is known as Davisson-Germer experiment. Okay, so this diagram shows experimental setup. It consists of three important parts. Okay, first part is a filament. This filament connected to low tension battery. When we are switch on this low tension battery, the filament release electron. Okay, it is known as a electron gun. Next, this filament connected with second part, that is high tension battery. This high tension battery connected with a collimator. Okay, it indicated by capital A. When the electron released from the electron gun, these electrons passing through the collimator. Okay, these collimators convert the electron beam into very sharp beam. It is known as a pencil beam. Okay, this pencil beam of electron moving with a high acceleration. This acceleration given by high tension battery. Okay, this high tension battery connected with the accumulator. When the electron passing through the accumulator, the electron converts into pencil beam with a high acceleration. This high accelerated beam collide or incident with the target. In the target, we are taking nickel. Okay, because of the nickel atoms, okay, all lattice points is equally arranged, equally same distance between them. So that's why we are taking nickel target. All lattice points should be arranged with a equal distance. So interplanar distance is a very short. Okay, here we are taking that interplanar distance d is equal to 0.91 angstroms for this nickel target. Okay, next when we are sending the high sharp electron beam to the nickel target, okay, due to nickel atoms, it will scattered and reflect back. When the electron scattered from the nickel atoms, we are receiving the scattered electrons beam with a movable collector or a movable detector. Okay, these movable detector connected to a galvanometer. With the help of this galvanometer, we have to calculate how much intensity of electrons scattered from the nickel target. With the help of this moving scale, we are calculating at which scattered angle the scattered electrons beam having different intensities. Okay, we are calculating these different intensities with the help of galvanometer, and we have to calculate scattering angle with the help of this movable circular scale. Okay, these total set of arrangement, okay, arranged in a highly vacuum chamber. Okay, this is the experimental setup of a Davisson Germer experiment. Okay, this is the 3D diagram of Davisson Germer experiment. Now we have to verify dual nature of electrons by taking some graphs. These graphs are known as a polar graph. Okay, we have to plot a polar graph between intensity versus applied potential energy by high tension battery. Okay, here we plot only few graphs. Okay, at 44 volts and 48 volts and 54 volts and 64 volts and 68 volts. Okay, we observe the intensity. Okay, the intensity of incident beam and scattered beam with different angles. Okay, we plot a graph between intensity of incident beam and scattered beam at a particular potential energy. Okay, we observe that from this all graphs, one particular graph having maximum hump formed. This hump formed at a 50 degrees of scattered angle and the potential energy is a 54 volts. Okay, after that we are increasing that potential energy, that hump will be decreases. Okay, finally it will diminish at a 68 volts potential energy. Okay, this hump will form at a 44 volts and this hump depth will be increases. That means when the scattered electron intensity will be increases, that hump will be increased. So by taking the intensity of scattered beam at 50 degrees scattered angle at a 54 volts, we observe maximum hump. Now we are calculating wavelength of electron according to de Broglie formula and Bragg's condition. Okay, by taking these two references, okay, we proved that electrons having dual nature. Okay, when we are calculating, okay, electron wavelength according to de Broglie condition, n lambda is equal to 2d sin theta, where lambda is wavelength of electron beam and n is the order. Next, d is the interplanar distance of nickel target. Okay, these all values are known. 0.91 angstroms is the internal interplanar distance of nickel target, and we are calculating Gansing angle. Okay, that Gansing angle is 65. Okay, so how to get 65? Already shown this graph. Okay, that scattered angle is 50 degrees, but the angle between incident to interplanar is a glancing angle. It will calculated by taking 180 minus 50 degrees by 2. It will get 65 degrees. This is the glancing angle theta. Okay, now this d value and first order n is equal to 1 and 65 degrees substitute in Bragg's condition, we are getting lambda value is 1.66 angstroms. Okay, this Bragg's condition only satisfied when that electrons having particle nature. If when electron having wave nature. If electrons are in particle nature, it's satisfied by Bragg's condition under that particle de Broglie condition. Okay, according to de Broglie condition, lambda is equal to 12.26 by under root of capital B. We discussed, we derived this formula in previous class. Okay, so here this potential energy we are taking at which potential energy the maximum hump is formed, that is 54 volts. So that's why we are substitute that 54 volts in this formula. We are getting lambda is equal to 1.66 angstrom. Okay, so here the wavelength of electrons according to Bragg's condition and the wavelength of electrons according to de Broglie wavelength, it should be same value. Okay, from these two values, we conclude that electrons having dual nature, that is particle nature and wave nature. It is one of the experimental procedure of de Broglie hypothesis. Okay, thank you.